All right, we're going to get started. Welcome everyone to our second annual discussion on open controls. So nice to see that we've got another full house. We had a big crowd last year at Atlanta, so we're going to pick up where we left off a year ago, and I'm going to just quickly introduce my panel here and then give each of them a few minutes to kind of say their piece on their perspective on open controls, and then we're going to turn into a bit of a discussion. Hopefully with lots of good questions from you guys in the audience. So to introduce the panel, first I've got Zach Nestoff, and Zach is a product specialist with Contemporary Controls and a contributing editor for AutomatedBuildings.com. And next I've got Calvin Slater. Calvin is a system integrator at Climatech and an embedded systems hobbyist and also a contributing editor at AutomatedBuildings.com. And finally I've got Nicholas Warren, and Nicholas helps companies survive and thrive in today's connected world, and he's also a contributing editor at AutomatedBuildings.com. You may be sensing a theme here. And I am Brad White with SCS Consulting, consultant out of Vancouver, Canada, and contributing editor at Automated Buildings. So with that, I'm going to get things started by turning this over to Calvin, and he's going to give us his perspective on open controls.
Okay, so the open systems interconnect model, you probably all heard of it, right? The different layers that make up networking systems. So Zach created this graphic, and we thought it was great. It's a great way to describe something different. The layers that make up our industry, basically. You know, at the bottom here, you have sensors, transmitters, actuators, communicating field devices. At the next layer, we have programmable field controllers, edge controllers, DDC, gateways. And then on top of that, we have all of our controller frameworks, site metadata, distributed self-documenting data structures, APIs. And then at the very top is the stuff that, you know, that's like the icing on the cake. This is what we want to get to. You know, like all the good stuff is up here. The stuff at the bottom is kind of like stuff that, I mean, DDC controller has been around for decades, so, you know, a lot of these things should have probably been resolved by now. You know, kind of like streamlined so that we can fully realize the goodness on top. So first let's talk about open source hardware. So as we all know, you have two types of controllers. You know, you have the controllers that are configurable, and you have controllers that are fully programmable. The difference between the two is a configurable controller is something that you will never have to change, you know, the control logic. You'll only have to change set points and different values. So there's a lot of really good configurable devices out there. You know, you install them, very easy to do. The workflow is very simple. You enter all of your, you know, different set points and values and take off, done. What I want to talk about is the fully programmable DDC controllers. You know, these are kind of a little bit more difficult to deal with. We've had some issues that have kind of been persisting for decades. One of the major things is that all of these programmable controllers take a different type of, you know, basically you need a different programming tool to program all these things. And now there's a lot of different programming environments for these things. So we might be able to solve some of those issues with open hardware. This is an example of a completely amateur-built building automation system. So I have absolutely no training. I'm not an electrical engineer. I did this basically as a hobby project. So a few disclaimers. So the cybersecurity disclaimer. It is the user's responsibility to define their own use case and threat model for these devices. it's the user's responsibility to understand and evaluate the potential hardware and software attack surfaces of the devices. That being said, you can make these controllers very secure. And one of the advantages of when you start to get into the hardware is you really start to understand the potential types of hacks that people can do, how people can get into these things, not only through software, but also physically tampering with the devices. And so I think it's really important, even if you're not going to make your own controller, to look at these devices and see, how if somebody gets a hold of one of these things, how can they tamper with it and potentially run their own code on these devices? Is it something maybe if somebody has very quick access to it, like they can just take out this SD card? Can't really see it here, but there's an SD card. If you just take the SD card out and you put your own operating system firmware on there, is that a possible attack to the device? Would that create problems for your facility? And also, product compliance is another issue. Product compliance is left to the user. It's a responsibility of the user to test and obtain certifications from applicable regional governing bodies before selling or deploying these devices en masse. I have not tested this device. I have not tested it. I've not had it UL certified or FCC certified. So, careful when you touch this thing when you come later. It could shock you. I don't know. Okay, so a quick bit of background how it's possible to make your own controller. So up to this point, the DDC control ever since they started having programmable controllers replacing pneumatics, all of these devices have been built using microcontrollers. And the reason for that is microcontrollers are, a very cost-conscious device. So you can make a device that's programmable and at the right cost where you can have hundreds of these devices deployed in your facility. It's not a great bang. But in recent years, the cost of some of these components have gone way down. And one of the key things that happened is kind of open source, if you want to call it that, licensing, where one company licensed its processor core design. You can design your own chip around that processor core, and it drives the cost way down. So we're now at the point where instead of using microcontrollers, we can use things that are basically, for the most part, personal computers. I mean, if you look at the red board on there, it doesn't have a screen, it doesn't have a keyboard, it doesn't have a mouse, but it's basically a miniature desktop PC. So the question is, if we have these devices now that are basically personal computers that are miniaturized, how can we turn them into a building automation system device? The answer is really simple. All you have to do is add 24 VAC input power management and circuit protection, industrial communication interface. So, these boards aren't made, they're not knowing that, maybe we want to have RS-45 ports and CAN ports. So you have to add those components. And then, of course, you have all of your I/O, your inputs, outputs, relays, analog front ends, addressing and configuration switches for, deploying them in the field. And then on top of that, durable industrial radiated connectors and closures. That sounds like a lot of stuff, but it's actually the easy part. The single board computer itself was like 90% of the engineering difficulty was to get a little PC on a board. Adding the rest of the stuff is really simple. So that's what I did. I added a fully isolated RS-45 port. I added a 24 VAC power supply. Pretty easy to do. Here's something that's very near and dear to me. These the way these devices are addressed. The people who install this stuff don't necessarily are able to think in binary. A lot of these dip switches, you have to set the binary address of the device. It's very hard to do when you're on a ladder and you're trying to look at the thing and you're trying to give it the right address. So I went ahead and put the rotary decimal address switches, which are still kind of hard to see, but it's a little bit better than thinking in binary. Added a real-time clock, relays, 6 universal inputs. You have 0 to 10 volts, 4 to 20 milliamps, and dry contact thermistor. Then I threw in another RS-45 port for a thermostat that I'm going to develop in the future. Of course, it has IP because everything's going to be going IP pretty soon, so you'll have both choices. You can use your RS-45 or your IP, either one. Micro SD and USB. It also has 4 gigabytes of eMMC built into that. You see that package in the center? That's kind of like a single board computer, but the people who manufacture that chip consolidated the individual components into a package even smaller so that you can save even more board space. So it's a single chip that looks and feels like a microcontroller, but that little square in the middle is basically a complete personal computer. So now the question is why? Why would you make your own controller? Flexibility, you can design your own control devices to your own needs. Maintainability, if you own the hardware, you can basically take care of the device for years, because you know everything about it. You have the schematics, you have the operating system, the bootloaders, access to all the source code, all the software. And that's why I did this. This is basically my home project. This controller is going to go in my house when it's done for my home automation system. Of course, it's going to run a Sedona SandStorm. SandStorm, if you haven't heard of it, is a complete implementation of Sedona. So Sedona is a framework to build DDC control, but what Anchor Labs did is they created a complete open source implementation. So it's basically the rest of the code that you would need to make a complete controller. And that's, when this thing's done, that's what it's going to be. So now we have Zach, and he's going to talk about open source software, which ties into SandStorm Sedona.
Hello everyone, I'm Zach from Contemporary Controls. At Contemporary Controls, we design and manufacture networking automation equipment that's built on open technologies such as BACnet, Sedona, HVAC, Linux, MQTT, you name it. I personally know that interoperability can revolutionize this industry just like it has many other industries. And it's something that users and manufacturers can both greatly benefit from. And I think that it's something we all need to demand, basically, and require. Just like you wouldn't buy an iPhone if it next an Android device, just like you wouldn't buy one computer that can exchange files with another computer. I think that interoperability is something very important in this industry and can make a great impact.
Hey, my name is Nicholas Wern, and also known as the Building Whisperer, because I can make buildings talk to people. Well, not I, but with the help of these guys, I think I can. So, I started in this industry 5 years ago, acting CEO. Well, I started international business development for a company that does hardware, software, cloud, Raspberry Pi, based on open source, all these kind of things. And I didn't know anything about building automation, by zero. And also 3 years ago was my first time at the HR Expo, and I didn't know anything either. I wrote about BACnet because the founder of that company told me that BACnet is like the best thing because it's interoperable, it's open, and you can do all these kind of things. And now, I think 3 years later, I still say the same thing. BACnet is fantastic because if you look at the Swedish perspective, for example, Sweden, BACnet doesn't really exist. So when we go into buildings, or companies go into buildings, there is no level of interoperability, not really. So digging out the data from existing controllers is painful, to say the least. It's at a Modbus level, you get a hard time getting rid of, or getting a hold of the Modbus tag list. The controllers are all super proprietary. You always have to call someone, and the integration costs are really, really high. Or you have to decide to go with one vendor, go for vertical, and just use their systems, and then you can, of course, use any other system integrators because you only specialize in one type of home controller, all these kind of things. So, let me fast forward again to where we are today, and we're talking about open controls and open systems. For me, who has sort of like taken this deep dive and understand some of these things, I mean, Kevin just told me that he wanted me to be more involved in this space and work on the controllers. It sounds like fun, but my background is international management and IT management and helping companies with strategies. My interest is more in how we can create fully deployable solutions, plug and play, and to more or less get rid of this stuff so that we focus on innovation more than integration. Because I think that's super important because climate crisis is here, more focused on the well-being, 330, 300, 3000 rule. And again, like in the session yesterday, we talked about obstacles and opportunities in the industry. We see that there are a lot of obstacles, but with any obstacles, there are a lot of opportunities as well. Attracting new talent, we get security, we get so many things that we need to do, and we need to do it fast. And again, like all this non-interoperable stuff makes it go slow. So that's also why this is super interesting, because I just want to be able to package this, or take Calvin is going to get the data out, or Zach is going to get the data out for contemporary controls, whatever, so that we can get it up to an IP level with standardized tag data, invite whoever we want to be able to innovate with the buildings that we see today. Because today, that's not necessarily possible. And I think that's what we're trying to achieve. I think open source, open systems, open and interoperable, I would say, with quality data is a necessity in order to do these things. Because again, you see, I talk a lot about build for the end. So a lot of the things that we're putting into buildings today is not built for the end. It could be the IoT strategies, it could be all connected, anything that you put in. Because it does the thing that it's supposed to do today, maybe to an extent, but it doesn't do what it's supposed to do tomorrow, or in 5 years, or in 10 years. So in the future, everything is going to be connected, everything is going to be like smart cities, smart buildings, and that requires quality data. That requires high throughput, that requires local control. And all this stuff, I'm getting actually pretty upset, but all this stuff with direct to cloud is so dangerous, in my opinion at least, because you gotta keep local control. That's where it's gonna start, that's where it's gonna be, and then it's gonna be an alternative to get it to the cloud, to augment it in a portfolio way. But it has to be there, otherwise you're losing the resiliency, you're opening up for the attacks, and then right now, again, like of course, Expected Security Connect is coming in, all of these kind of things to make buildings more secure, but they're not that secure, not yet. And again, that goes back to the openness and the need for interoperability, not only in the technology sense, but also collaboration among disciplines so that we can make the building secure in order to focus on well-being, all these kind of things that we need to do. So, yeah, I mean, that's what I'm all about. So, yeah, I'm the CEO of a company called Vinio. Help companies with all these kind of things, IoT strategies, basically, yeah, helping companies to survive and thrive in this world today in real estate. Thanks.
Yeah, thanks, guys. And I think the one thing I heard, that really resonated in my experience as a consultant is, when Calvin mentioned this idea of making sure you're able to kind of keep control over the hardware, software, the product. And I just, a story from our experience is, we were looking for a low-cost solution to acquire data from the BAS systems so that we could use it for analysis and energy audits and recommissioning and all that sort of thing. And we found a great product and been using it, started to deploy it at a number of jobs. And then decided to stop selling it. And we were left hanging. And we couldn't support the deployments that we had, and we couldn't get any more. So that was what originally drove us to an open source project that was originally developed by the DOE called Voltron, that we can then put on pretty much any piece of hardware and then use that as our data acquisition platform. And yes, we had to develop a little bit of infrastructure for software interface and some server infrastructure to support the data. But in the end, that being worth it for the fact that we know that solution is ours that we can control now, and I don't have to worry about a vendor deciding to take that product off the market or stop supporting it. But that's just one use case of where we've found that open source has had an advantage over commercial, standard proprietary commercial product. But maybe to get the discussion started, Calvin, question for you. Your open source controller. You said, yeah, I'm going to put this in your house. Would you put that into a client site today? And if not, what do you think it would take to get something like an open source controller to that point?
No, not today. Right now, actually the hardware, it may not seem like it, but the hardware is the easy part. Quality software is more important than anything. Software that's stable, that's developed and proven. So right now, this thing has all the hardware it needs to be a controller. Of course, there's, the certifications are still needed. But all it has is an OS. It has a really good OS running on it right now. It's running a Linux operating system, Debian, which is very popular with these single board computers. So you have a really solid foundation to build a good product. But there is just months and months of software development that needs to go in there. Of course, like if you're looking at like Sandstar, you already have examples of complete running, like basically every need for DVC control. You have basically, what was missing from the Sedona kits was a I/O kit that is because they didn't know, when it was made during the microcontroller days. So microcontrollers need a very compact and device-specific firmware. So I believe that the people who created Sedona, because it created for microcontrollers, they couldn't say like, okay, well, your I/O is going to be exactly like this, because on a microcontroller, the software implementation is very specific to the device. Especially before they had C compilers for the devices, you had to actually write in assembly language, so they didn't know what the I/O was going to look like. But now that we have basically PCs, a lot of that is kind of abstracted away. So, Anchor Labs made a kit that pretty much will work on any Linux device directly. And not only that, you could take that source code and you could recompile it on, say, Android system, or you could do some adaptation porting, and you can actually make it run on every device. But to answer your question, like yes, lots of software development, lots of testing before you deploy to these device. If your air conditioning goes off at home, that's one thing. But I believe a lot of like this controller right here. This controller is much farther along the way. This has been deployed for years now, actually. This, I believe it was a company, Solidyne, and then now it's the same hardware and most of the software in the EAC controller that BASSG sells, and these are out in the field. They're running. They haven't had issues for years.
Is that open source?
Well, the software is open source, but I don't know. Alper, are you going to open source? I believe he's working on some open source hardware devices as well. But having open source, a hardware board that is open to adding your own software is also a very big step. Like if we were to have controllers where they give you an OS and then you have the choice of all the applications and type of DVC that's running on the device, that would be like a leap ahead of anything that we're looking at right now.
You want me to answer?
Yeah.
Yeah.
So the devices that you see in here, this is the VAV. In the room, maybe Trevor is here.
Albert, could you just do a real quick introduction of yourself?
Yeah.
And maybe some people, believe it or not, there may be some people who don't know who you are.
Is there anyone that doesn't know me yet? No, my name is Alper. I've been in the industry over 20 years. Started with graphics and became 3DM and SkySpark distributor, and been inventing. I call myself innovation worker. So basically, we've been working on Project Sandstar over 3 years. The goal of the project is to merge Haystack with Sedona framework. How many of you heard of Project Haystack so far? All right, like 30%. How about Sedona framework? All right, it's about the same size. So Project Haystack and Sedona Framework is written by the same person that wrote Tridium. He's the genius of our industry, Brian Frank. And we basically merged the two technologies together to create hardware abstracted DDC. So what does hardware abstracted meaning is that we have controllers, we have inputs and outputs, we abstract it to the use case that we have. So you have zone temperature sensor instead of AI1 when you get to the logic layer. So that's what Project SenseStar does. We do have devices. I'm not sure if Trevor is here. We have installed these rooftop, the VAV box with him. Bob Rayner here, we installed a rooftop unit and it has been working over 2 years in Florida. There's another controller that we have built. It's almost like the second version. This is a PoE VAV fan coil unit controller. So this part, if any party in here would want to build manufacture these in mass, contact us. We are okay to give you this BOM files and the code and the design so that we can manufacture open controllers for different use cases as well. So we do want to open up the controls market. So the other thing within SenseStar is that the Sedona code, the SenseStar code is portable between devices as long as your IOs match. IO count matches between each other. So that is the most important part of the application stack. Thank you.
Thanks, Alfred. That was a good addition. So, I mean, as you can see, there's a lot of pieces, I think, that have only very recently, I mean, how long has SenseStar been around?
We've been working on it 3 years.
3 years. So, and I think, things like that are an important piece of the puzzle that, without folks sort of dedicated to developing the open source software and hardware, you're just not going to have the things that you need to make this happen. Any questions or comments from the audience before we move on? No? Okay. So I guess, the one question, and maybe I'll play devil's advocate here, but can the open source compete in terms of reliability if you've got a manufacturer that's got a proprietary system, but they've tested all the components with each other, they've made sure every piece is interoperable and it works well together, and now we're going to come along with open source components that who knows worked on them and developed it. Is it possible to achieve the same level of reliability? Because I think that's something that customers are going to want to know before they want to put it in their sites. And maybe running a rooftop unit is one thing, but what if you're running 500 VAV boxes, a big network? Do you think that's achievable? Or maybe Zach and Cal? Is that, like, how far away is that, or is that, like, could we do that today?
Yeah, so basically the way I see this is that the interoperability layer has to be maintained, and then the proprietary layer is something that could be like an enhancement on top of the interoperability layer. So if everybody maintains interoperability and these things can talk to each other, then proprietary is where manufacturer A can shine over manufacturer B in terms of features, workflow, ease of use, quick deployment, enhanced security features, so on and so forth. And just like Calvin said earlier, obviously when you're developing something new, it has to go through a ton of testing, certifications, things like that, and that's how you make a product that's robust, interoperable, and enhanced.
Cool. So now maybe I'll ask a question. So I mean, we've talked about a lot about true open source stuff where it is open and you can develop on it. But there's an awful lot, I think, especially on the software side, and some of the stuff that we're seeing, third-party applications that they're not open source software, but they are doing things like making APIs that are sort of industry standard APIs and they're open and accessible. Like, is that a piece of this as well? Like, because not everything is going to be open source, but I guess where do you see the market evolution in terms of more third-party software developers doing that sort of thing, but publishing APIs that make the data easily accessible, and where does that fit into this? Anyone want to comment on that?
Yeah, so it's an interesting question, and I also agree with Zach in that sort of over here inside the building it should be interoperable, open APIs, and that the data should be standardized. And I think like Phil Cito, who runs building automation monthly, he posted a question on LinkedIn. I think we got like 50,000 views or something with a lot of comments, and that are we seeing the need for one universal programming language in buildings, right? So you take all these controllers, you knock them, well, with a hammer, it's almost, you get out the data, and then it flows up to one API for the whole building, and what are we gonna do then? It's gonna be Java, and all these kind of things. I've been in the same discussions with software developers and think, okay, just get me the data through a RESTful API, and then I can use Python, Java, or whatever. The problem there is if anyone has worked with developers before, no one wants to work with someone else's code. So if you do that, which is, I mean, it's a great idea to an extent at least, then you're gonna run into applications, and then that's okay, maybe that company's gonna go bankrupt, and then you hire another developer firm and say, yeah, this is based on some open stuff, maybe not open source, but it's not been documented. And even if it's been documented, that new developer is gonna come in and say, yeah, we can do better. Or we can do this in another way, even though that it works, because that's sort of how it's being done. So what is the solution then? And I think going back, I mean, standardizations like BACnet or haystack tagging, risk schema, and ontologies, that has to be there in order to augment the data, and that's what you have to build on. But you also see on the top layer, once you get the data out to some extent, and like what master systems integrators are doing in getting the data from different controllers, taking it up, asking the customer, okay, what do you really want to do? I mean, not what you're limited to, but what do you really want to see for the tenants or for your economy department or whatever it is. And that makes it possible. We see this like Willow in Australia, they're making an app store for buildings. So they're taking it up to this level, they're using a digital twin approach, and again, like creating an app store where the APIs are there. We see ecosystem forming where API, builtapi.com for instance, where they collect APIs. So something would have taken like an integration effort, I would say, I don't know, 10 weeks, 5 days, whatever it is, can happen like 5 mouse clicks. Because you have the APIs standardized, you have them in bundles, all based on standardized and tagged data, and according to, well, whatever standard you're prescribing to, you can do this in a heartbeat. And you can do this for different vendors. And again, like looking at the smartphone as an example, the hardware is there, but I mean the value is in the software. The values in the ecosystem, the values in the applications that are built on top of open source or the openness in the app store. So I think that's the evolution that we're seeing with building as well. But I mean, we're 20 years, 25 years after everyone else, or after the IT. So if you're looking at IT, OT, IoT conversion, whatever, again, we're 20, 30 years of what can be done. And we have to get there as soon as possible. And the question is how we're going to get there. And I agree, open source, open, whatever it is, I mean, as long as it's interoperable and it's adhered to some standard and you can inject it with schemas or some kind of augmenting factor that someone can work on it in a standardized way, that is the most important part. So, yeah, that's my sense.
Did I ask a question?
Yeah.
Have you ever heard about Wi-Fi routers being spaced throughout the building? That it's best to put them on the same set of legs so you can minimize interference? You know, ABC, right? So if you start off, stay with AB or BC or something, don't mix enough power, let's say, you know, 208 off of 2 different sets of legs, because that causes a lot of
Can you please stand up, maybe, and speak louder? It's difficult to hear.
The router should be dedicated to A and B, or B and C, or A and C, and not mix them throughout the building when you're trying to set them up, so that you can push things out to the devices. Have you ever heard that? Use that?
Not necessarily, but we got a question yesterday, right, so from one in the audience during the obstacles and opportunities session. And there was a question, okay, we run into, there was also one of the obstacles that one of the other panelists said. So getting in buildings connected through Wi-Fi or whatever it is, or opening up IP addresses on the IT network, you're always running into problems with the IT department, right? And one way, then we got the other question, okay, how do we do this? How do we solve this? Do we make it into an argument about the money, blah, 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 blah. But then afterwards, like a couple of hours later yesterday, there was this other company who worked, I think it was, what's his name, from Penn State, and they just set up a completely separate OT network. So you have the IT network, but then they set up a OT network, and I think like the Wi-Fi is one thing, but if you're talking about wireless in buildings, that's not necessarily Wi-Fi. It should be different because Wi-Fi is maybe not that secure. So if you have like some wireless mesh or something again that prescribes to local control in a secure way, that's how you should do it. And maybe just having a separate OT network, and then you do some tie-up at the end, and you don't have to involve IT department because you're doing it that way. I'm not really sure if that was the answer to your question, but in terms of the discussions that we're having in terms of Wi-Fi, reliability, security, as well as scalability, again, like wireless mesh, in my mind, having looked at almost all the stacks that are out there in terms of IoT, or like LoRaWAN, LPWAN, all these kind of things, wireless mesh is the only one that fits the bill in terms of all of these things. And build for the total cost of ownership, because if you install something else, it's going to break, it's going to be ripped apart, the packet loss is going to be immense, you're not going to see the benefits with analytics, AI, machine learning, and the total cost of ownership is just going to skyrocket after a while. It's not going to work. So, I don't know, does that answer maybe or not?
Well, you know, a lot of HVAC stuff is hodgepodge together, unfortunately. And I just seen a few times I've tried it, that I see to get more reliability, pushing information out and getting it back. On the wire belt, you know, if it's a wireless setup. And I was trying to see if anyone else had seen similar feedback. Because when you start putting things on different, it's like Honeywell years ago had something where they used the power lines inside the building to send information. And I don't think they filtered it out very well and it worked very well because maybe issues like that and mismatch, you know, phases. You know, instead of
You mean with power line communication, or? You mean with power line communication, or what did you say?
this is probably close preview.
Yeah. No, I know that Lone works in Echelon, they had their PLC stuff, and I know about Lone Plug as well and all these kind of things. But
Quite a few years back, I was trying to get back that has anyone else really seen it that really helps us?
How would you get back to open? We're getting a little far off the top.
Yeah, and you know, that is a great point, is the reason we're looking at this stuff is, you know, the compatibility of control devices across a facility. You know, sometimes you have like multiple different control frameworks in all of these devices. The main advantage of open software and open hardware is that you can, across the board, streamline your entire facility. You know, what I see in 10 years is you'll still have controllers that are manufactured by, you know, the major manufacturers. Probably the vast majority of deployed devices are going to be by a large manufacturer because they'll just be able to make them really cheap. But I think the difference is going to be you're going to start to see them opening up the hardware, you know, allowing you to add different applications on your own without artificially limiting that. So you may have a facility, you'll have, you know, maybe 90% it'll be a hardware from the major manufacturer. Maybe you'll have some custom hardware, but you'll be able to put, you'll have total ownership of your entire facility. You'll be able to put any software you want on these devices. And you know, by allowing people to mix and match hardware and software, you can completely streamline a facility instead of having, you know, 5 different types of DDC running and then kind of like Frankensteining, you know, all this stuff together by network. You know, that's what we're trying to eliminate. Question?
Yeah, I mean, actually thinking about Wi-Fi, you know, I think it's an interesting model because like access points typically are made by what's called original design manufacturer, an ODM, and like you can buy essentially stuff made in the same factory from, you know, TP-Link, it's the cheapest thing on Amazon, or Cisco or Meraki, and like the differentiator is the software? Like, do you think we'll see that? Do you think we'll see, like, when I walk the show floor and look at the Johnson and the Delta, like, they're all got very different form factors, like, you know, they're differentiating themselves in like almost a physical basis. Do you think we'll see like convergence of them using a similar or very similar hardware platform and then offering value with the software that they're putting on top of it?
I believe so. You know, one thing that I saw a recent announcement was that the home automation industry, a lot of the, you know, the Googles and the Amazons, they're very quickly moved. You know, they have all these Wi-Fi devices, and now they're starting to say like, hey, let's standardize these wireless communication protocols. And they already launched an initiative. I forget what it was called. Was it CHIP or something like that?
It's an open IP protocol.
Yeah, an open IP protocol, so that all of these, you know, home automation devices will talk to each other in a seamless way. So I think that, you know, as far as like wireless and devices, at least you should be able to have the choice to say, you know, I want these type of access points across my facility, and I don't want to be stuck with hardware that's tethered to a certain type of device, you know, because of course, like a wireless access points can be a huge security risk, right? You know, you want to very carefully control it. You want total ownership of that hardware and software, definitely.
So, you know, Calvin, you said you think the major manufacturers are going to open up to allow kind of more flexibility with software, and you know, I think Zach raised this idea of an app store. Like, you know, what's to stop someone like, let's say, Johnson or Tritium, and I'm not picking on anyone in particular, just, you know, the folks with large market penetrations, but to say, you know, we're going to build our own app store, and that's going to be our special sauce because we're going to have the most apps and the best environment, and we're going to attract people to our product by having, you know, the most applications, and we're going to get it. But that's going to be a closed ecosystem. We're not going to just open that up to allow, you know, Tritium apps to run on Johnson systems, and you know, you got to develop for that environment. Like, do you see that as an alternative model that they might try? Because I mean, I've already seen, you know, some manufacturers, not to that extent, but to start to develop their own platforms and have that be the thing that is their differentiator. And to me, that's not really open source. That's, or not even that open. I don't know. What do you?
Yeah, I have something to add to that.
Yeah.
So basically, I kind of see what you're saying. So basically, it's kind of like you can think of it as like an abstraction layer. So if you have a system like a Linux operating system, for example, one thing we've done at Contemporary Controls is we've developed something called the BAS Pi, which is a controller based on the Raspberry Pi. I'm sure that a lot of you people have heard about the Raspberry Pi micro PC. And basically, that firmware that's running on a Raspberry Pi with a specific I/O board with 12 points can easily be transferred to something like a TI chip that's also running Linux. So basically, the portability of that code is something that we kind of take advantage of. And I think that can be done on a larger scale. So that's basically what I had to add to that.
Question?
Yeah.
Yeah.
Can you merge the Raspberry Pi system with a Sedona so we can like have both features available in that same basket and we can access it?
Yeah, that's basically exactly what we've done. So basically, what we've done is we've taken industry standard.
Could you repeat the question there?
Yeah, can you repeat the question?
No, you into the mic.
Oh yeah, he was saying if we can support technologies such as BACnet or
Sedona.
Yeah, so basically that's exactly what we've done. So we've taken technologies that are industry standard technologies such as BACnet, Sedona, Haystack, web page for configuration, RS-485 ports for communication, IP ports for communication, Wi-Fi for wireless communication, and basically we've created firmware that could easily be ported to other devices, such as, you know, you have a completely different hardware. You have a Raspberry Pi with a Broadcom CPU, then you have a TI chip that's running on a BeagleBone, or we actually even made our own single-board computer with a TI chip. So that code can easily be ported to all these different platforms. They all run Linux, so that kind of abstracts a lot of things. So I think that in technology, abstraction is a very interesting topic that basically solves a lot of problems for us.
Nicholas?
Are those data between the Sedona, like whatever the IOs available on that, and GPIO, right?
Yeah,
There's
exactly.
GPIO, there is a
Yeah,
6
exactly.
universal, a 6 output on that basket.
Yeah, exactly.
So those hardware data between those input and output and those 40 GPIO, can those data talk to each other, transfer between the two layers of the Raspberry Pi and the Sedona?
Yeah, exactly. So that's what we've done. So basically, we have backnets, Sedona, all integrated into one firmware, and it's portable on different hardware devices.
Nicholas, you
I
want to jump in?
have
Yeah.
I think I know. That is a very technical question, thank you. Yes, so he was asking, you know, when you say GPIO, they're talking, general purpose input and output. One kind of really interesting thing about these operating system-based controls is the people who work on, especially Linux, have really kind of standardized the way that you interact with hardware, and they've done a lot of work. So when somebody says GPIO you would use maybe for a relay, you know, if you want to control a relay on or off. The people who work, you know, with Linux, with no knowledge of the controls industry, have created a standard way, you know, through system calls of how to actually flip a bit on the output pin of this device, which I use to drive a current driver to drive the relay. So they've already done a whole lot of work that we don't have to do. You know, for example, you have a universal input on, you know, one of these controllers. Universal inputs use analog to digital converters. You know, basically they'll take in a voltage and they'll give you what's called a count. The people who work on Linux didn't even do this for the controls industry, but basically they created a way to take hardware such as ADC and bring it directly into the system. So if you want to create, so there's only one more layer of software that's missing, right? Like for example, like Sedona, you need a kit that will make that system call to flip that bit or to get that ADC to get your temperature sensor, you know, because the system call is already there, right? So you need a piece of software that's gonna say like, hey, what's the ADC value of ADC1, or please turn on this relay, and then bring that up to the DEC layer. And that's what, you know, that's what Alper has demonstrated with Stanstar. He created that last piece of glue that lets you glue the system call level to the DDC level. And in doing that, it's portable across Linux. So, you know, no matter who makes the chip, you know, what distribution of Linux, the system's calls are either very similar or exactly the same. So it is very easy to take his Sandstar software and, like, as a matter of fact, I'm going to do it next month, is I'm going to take his software without any coordination, I'm going to put it on this device, and it should run very easily because his devices are actually almost the same processor. But even if you had a different processor, if you had a Raspberry Pi, you know, now they're up to the ARM v8 architecture, so it's a 64-bit architecture, so it's a different instruction set, and still, just because the fact that the Raspberry Pi runs Linux, those standard system calls are still there. So all you would have to do is basically recompile, like say Sandstar, and you could instantly have a controller that runs on a Raspberry Pi and has access to the I/O in the same way. It's very, like the people who worked on Linux and worked on these processors, they've done a lot of work, and they've done a lot of work for us and streamlined everything very, very well and very nicely. And you know, if you follow this stuff, you'll see there's now a RISC-V architecture, RISC-V. It is a open instruction set where you can design processors that have the same architecture, and it looks like going forward a lot of the major manufacturers are going to now offer even cheaper processors that are all standardized. So they're really, you know, people at the low level of the hardware and the operating systems have just completely done, you know, a great job streamlining the stuff, and they made it very slick, and they made it very easy for us to do our job. you know, so, and those environments are something that a IT person or, you know, the new OT person will understand easily. Being able to update these systems, and being able to patch and maintain, and they don't really have to have any knowledge of HVAC. You know, to them, they're just saying like, okay, this thing's a PC that runs Linux. I'm gonna keep this running, I'm gonna keep it secure, I'm gonna keep it updated, I'm gonna push updates to it. And then the system specialists, the HVAC people with the knowledge of DDC sequences, they maintain the stuff, the applications. You know, it's actually just like how office equipment is your IT department maintains your computer, and you have like AutoCAD and all the tools you need to do your work, and they're completely separate from one another. You know, every time somebody does something that messes up somebody else's stuff, but there's still that layer of separation. You know, the IT people don't have to know how to use like a BIM modeling tool. All they know is that they want to keep your machine updated so it doesn't get hacked into or outdated. And that's what we're talking about. I don't know. Does that make sense?
I just want to comment real quick on your question, Brad, about I mean, we had protocol wars, loan wars back in that. Your question was more like, is it going to be like an app wars, right? And yeah, absolutely. But that's a good thing. It's a really, really good thing, because if you're at that level, that you've abstracted the data, you're taking out the data from the building to one API or several APIs, and you're putting that data in control of the real estate owner or whoever it is who wants to get a hold of it, then there's going to be an app store, of course, or an app store wars, because you can get the data to any cloud infrastructure, and then you can put it to any app store, and then you can utilize their apps. If you don't like it, you take the data back and you send it somewhere else. And that's the level where we're not at today, because again, like you spend a lot of money on integration, getting the data out, and then this might be the case. In getting the data out today, so leads to an app store. A lot of players take the data, and if you want to use it, they have to use their proprietary stuff. You have to use their tools in doing it. But all this stuff with open, I mean, for me, when listening to Calvin, it's just open should give you the possibility for flexibility, for choice, for control, to be able to do these things in a much, much simpler way, faster way, and in an open way that we're seeing today. And yeah, there's going to be a lot of competition in terms of app wars, platform wars, which we're seeing now as well. I mean, even for me, it's extremely difficult to understand where things start and stop, because all the platforms that are out there can do everything, which of course is not true, because they probably can't do a lot of different things. And there's a need for proprietary solutions at the top. So again, you have the data, and then there are 5 proprietary solutions that does the job well, and then you select the best one. And the best one, that's the one that should win, not the one that is most proprietary, or whatever it is, or the ones that got dibs on the building because they installed something 20 years ago. I mean, that's crazy. So, yeah, isn't it? I think so. So just getting the data out through open interoperable systems, that's going to lead to open ecosystems where, yeah, all these wars between rivaling products, and the best one's going to win all the time. But again, getting the data out, putting that into control of real estate owners, or real estate owners allowing someone or inviting someone to innovate with the building, that's the whole point of this, in my opinion. So, yeah.
So far the DDC building automation is localized. Sometimes they export the data to the web server, or somewhere the Tritium platform has that, right? And you have the data, keep it stored, or maybe you have a station dedicated. But so far there is no smart building application implemented into the DDC controllers. So those data are analyzed by someone who knows the system thoroughly. Otherwise, it doesn't say, hey, this is my ROI on this equipment, this is a consumption, this is my saving. There is no data analyzed so far in the DDC controllers. But can we put the SkySpark?
It's already in there.
It's already in there?
It's already in there.
Okay,
That's
so
your
that's
answer.
Yes.
Yeah, you can never see one. No, but I mean, I think that the question, if I understand it correctly, I mean, all this stuff, again, going to the cloud or doing this kind of stuff, you just put it at the edge, where all the data is. And then
That's
again,
what it's like Passive Logic is doing, right?
yeah, or everyone, I mean, you should do it. I mean, this is exactly what Calvin and Zach are talking about. All this stuff that is now is proprietary to some extent to these big vendors or whatever. it's going to be open. You can put it anywhere, and then you can invite whoever system integrator you want with the right skill set to work on that data. And all these AI machine learning platforms that have been proprietary or confined to these vendors or whatever, it exists. It exists today. I mean, I was just in a demo. Ken was there, some other people as well. Where this is where they're showing. They put in a gateway, like $50, like this Kodi TV home automation stuff. They put a software in there that can extract data from the backend network. They take sensors just above the what we'll call the battery tab. That communicates to the gateway. Everything becomes backnet, and then you can do whatever you want with it. So you're just like hijacking the data from existing proprietary controllers. There's so many companies that does this. But I have the list, so if you want it, you can come to me, of course. Yeah, so I mean, this is being done, but I mean, it's in scale and it's openness, and it's not really there yet, obviously, because again, open, you have a controller that is open, you get the data out, but then you don't understand what it means. Or you have the proprietary drivers that you have to pay for the vendor to get access to. All these kind of things is not open through and through. So again, open source, open, interoperable, there are a lot of different facets, but I mean, yeah, if you want it done without vendor lock-in, it can be done, absolutely. And it should be done.
I agree with that. There's absolutely no technical reason why a few devices can't talk to each other. So basically, at the end of the day, I feel like building owners and system integrators, they don't really care whether you have a plugin, an API, a gateway, or an open protocol. They just want these things to work together so we can actually accomplish the goal of saving energy and providing comfort. So I think that's the bottom line. Like, we can get technical here all day, but basically the bottom line is that these things need to work together first to get to the icing on the cake.
Well, and I think a theme here generally is moving towards separating the hardware and software in BAS controller. Because right now when you buy most BAS products, like you're buying the hardware and software together, and like they're inextricably linked.
Yeah, you gotta decouple it.
Yeah, that's what we're talking about, is moving towards decoupled hardware and software. You can mix and match hardware and software. And I think Zach used the example last year. In the situation we're in right now, it's kind of like you've got a PowerPoint presentation on your Lenovo PC. You can't move that over to your Dell PC without totally rewriting it.
Yeah, right. We'll call it Lenovo.
Yeah. So moving towards a world where you can have more portability of that software and applications between different systems without having to recode it from scratch every time. And I think that opens up a lot of possibilities that just don't really exist right now in our industry. So, I don't know, any more? We're getting pretty close.
Question there,
Couple
sir?
minutes? Yeah.
You got time for one more?
Yeah.
Okay, I'm all for interoperability, and we see buildings becoming a larger mix of our energy, distributed energy resource, DERs, if you will. And where do you see cybersecurity in all this? Because as buildings play a larger role in our critical infrastructure for energy, it also becomes a bigger concern for cyber attacks and whatnot.
Well, I mean, that's something that open source gets hammered on for a lot, is the security aspect. So,
I'll take a crack at it. I know we got. Yeah, he's got an answer too. That's going to become a central issue, is cybersecurity. The best way to make your system secure is to have a complete view of the entire system, like all the way down to, because now we're looking at attacks where people are tampering with hardware, where people are putting implants on devices. It sounds kind of crazy, right? Like, how long is somebody going to have access to a VEV box controller? But you could actually do stuff to a control device where you're running code that you don't want to be running, and that's how people get into the system. People might be able to get into a BAS system from the thermostat. One of my favorite hacks was the G-packing. If you guys look at that, look at DEF CON G-packing. That is a prime example of what could happen, what we don't want to see in the building automation system world. And the problem with that was no person involved in that had a complete view of the entire system. If you look at the video, you'll know what I'm talking about, because it involved the head unit of a Jeep. And the car people didn't understand all this software and stuff. They didn't understand what they were selling. There was a huge security vulnerability there that they just weren't aware of. Nicholas?
Okay, I think that's a fantastic question. Because security is something that not a lot of companies talk about, to be honest.
That's why I brought it up.
Yeah, exactly. So I really appreciate it. So I mean, so I'm trying to sort of get a grip of what's going on more or less. And again, like without being super technical, I think it's just not one company can do everything. So you just have to understand. So okay, first you take intelligent buildings, for instance. They do all sort of security assessments. So you know what you have today, right? Then you can take something like tempered networks. They do a cloaking of everything that goes on. So if you scan, so like the network from the outside, you're not going to see anything. Then, of course, if someone comes in and tampers with the controllers, then maybe you have on the hardware layer, you have something like MSP, like device level testing, and you just have all these different products or companies that are performing various parts of the solution. Order.net does something with the existing system, Totem Buildings does something else. And that's what it's got to be about. I mean, understanding where you are today, understanding what you want to do as well, and partner up with companies that can solve that problem. That's the only thing that is, that you have to do, and that's the thing. But it's extremely important because again, like we're opening up buildings and we're connecting them, and today buildings are extremely open. Benefits with backlinks, of course, downside as well when we're doing this connecting. And I mean, secured by symmetrics. All of these kind of things. Everyone has a role to play. So.
Okay, Zach, quickly.
One quick thing. I just had a quick practical example about the cybersecurity question. So basically, as you all know, IT is booming and it's growing very rapidly. So there's something called MQTT, which is an open source protocol. It's basically the de facto protocol for doing IoT. But those of you who have like some kind of technical background on this, they probably know that MQTT is not secure by default, like at all. It's completely invisible. So basically what you do to make that secure is you use another technology called TLS 1.3 at the moment, or SSL as most people know it. So basically MQTT plus TLS or SSL is what gives you security and interoperability at the same time.
All right, I see there's more questions. We are past 1 o'clock. So I think I'm going to officially shut the session down. Thank you all for coming. But yeah, then we can continue the discussion. We're going to stick around for a bit. But I'll officially close it, and thanks everyone.